Oh, this is great. Thanks for the invitation to be here. This is about forestry, so a bit different than some of the other topics. And now I'll see if I can figure out the technology. I'm a forestry person, so the technology may be difficult. Perfect. Okay, so again, this is kind of a tools session to talk about some of the tools that you might use to analyze forestry impacts within your country or within local communities within your country or across broad segments of Asia. In the spirit of thinking through tools, I thought I would put a diagram up of the sort of list of tools that you might have to use in terms of forestry analysis. And this, forestry is a bit different than agriculture in the sense that it's a stock resource. If you're going to grow trees to manage them for forest products, it takes many years to grow trees, and climate could change quite a lot over the time period in which you have the trees growing. So it's actually a pretty complicated set of decisions if you think about how to try to manage trees with respect to forest outputs or even carbon sequestration for people who think about carbon sequestration, given that climate might be changing over the time period those trees are standing. So the tools that we typically think about using in terms of analyzing impacts and adaptation in forestry, we have to use things called ecological models to assess the ecological impact of climate change on trees. So sort of drawn this set of scenarios that if you're going to analyze forestry, you kind of have to start with the climate scenarios. So the general circulation models that give you some sense of how climate is changing. You then maybe need to use ecological scenarios, assessments of what may happen to ecosystems over time, and then link those into your economic models. So the economic models really are kind of at the end of this set of models you'll need to use in order to understand the impacts of climate change on forests as well as the potential adaptation strategies. So keep that in mind that there's a lot of tools. And what I'm going to do is work through the ecological scenarios and talk a bit about those and try to give you a sense of how you need to take those results and use them in economic models. And I'll give a little bit of a discussion about the economic models. So what kinds of ecosystem impacts, when we think of these ecosystem models, are we going to be interested in if we're trying to assess forestry? So the first set of ecosystem impacts are going to be the productivity impacts. So climate change will alter growth of trees by making it warmer and wetter. In some places, warmer and drier in others. So in warmer and wetter places, trees are likely to grow better. In warmer and drier places, trees are likely to grow worse. And there may be even some more devastating impacts than just growing more slowly. But also importantly in forestry is the idea of carbon fertilization. And it seems to me that ecologically, reading in the ecosystem literature, that now there is a broad understanding that carbon fertilization generally has a positive effect on tree growth. Most trees are C3 trees, and so that additional carbon in the atmosphere should enhance tree growth over most of the earth. So when you see a lot of the ecosystem results with respect to climate change, especially in this coming century, many of them turn out to be positive. That is, they look like there's a lot of additional productivity in terms of forests, and that's driven heavily by carbon fertilization having a positive impact. So keep that in mind when you see some of these results. Also, in places where it becomes warmer and drier, there's concern of increased disturbance events. And so there is, within the ecosystem models, there are a set of these models that project changes in disturbance regimes. And disturbance is really important for forestry. It's a stock resource, a standing set of trees. If they're susceptible to additional disturbance in the future, that is forest fires, bug infestations, other kinds of things that harm tree growth and ultimately kill off trees, then this can have an important productivity effect, both for the forest and potentially for the services such as the forestry outputs that countries are interested in gaining. So disturbance is an important ecosystem effect that has to be modeled and understood as well. And finally, there's the idea that species are shifting, and I'll present some maps of that. That is, where trees grow ultimately is projected to shift quite dramatically as a result of climate change. And within countries that have long distances from north to south, it could have pretty big impacts on the types of trees that actually exist in those countries over long periods of time. So keep that in mind. And I'll work through some of these results as we go. How do the ecosystem models work? The ecosystem models that I'll be using, and I think most ecosystem models tend to operate on the same way, they tend to try to model carbon. So if trees are essentially carbon, they take carbon out of the atmosphere and store it in woody biomass. And so what the trees are, or what the models are trying to do is to model what happens to that carbon over time. And they essentially do that by modeling tree growth and the things that subtract from tree growth. For example, the disturbances that potentially kill off trees and the decomposition of the litter that falls when trees, for example, lose their leaves in temperate zones in the fall. So keep in mind this is mostly what these models are trying to do is assess what happens to carbon over time. The models I'll be talking about are these dynamic global vegetation models. I'm not going to go into great detail. I can't go into great detail about those other than to think about the results that come out of them. So the results I want to talk about today that will be used in economic models are these key parameters, shifts in the range for timber species or biomes. Is a really important thing. I mean, if you're in a place where you're trying to protect forests, and those forests indeed are moving from one place to another, this creates a pretty complex protection strategy, how you actually protect them when ecologically they may not exist there in 30 years. And so these dynamic global vegetation models actually can help provide some projections for that. Also, natural disturbance losses, the dynamic models can help give a sense for what might happen to disturbances over time. Net primary productivity, they can give a sense for what happens to the growth rate of trees over time. And then also total carbon stock in forests, so give a sense for the what's the net effect of all these three processes going on here. The total carbon stock is essentially that. They can do this at many scales. I'm going to talk about them at the half-degree grid cells, but note that these dynamic global vegetation models can be actually reproduced or implemented at a much more spatially discrete level, so 30-meter level. I've seen them produced at a very low level of aggregation, so that if you have interest in using them, increasing for both forestry products and for bioenergy products, it is having an impact in forests. Rising opportunity costs that are leading to land use changes, and these efforts to protect forests from land use change, i.e. conservation, and I'll try to give you a sense of how to think through that using some of these climate results. And of course, climate change actually adds perturbations to a pretty complex story that forestry is already facing. So if you're doing economic modeling, these kind of elements really need to be involved in or included in the economic analysis. Okay. So again, I'm using these ecosystem models, just to keep that in mind, just a slide to sort of remind you that I'm trying to take these ecosystem models and incorporate them into an economic model. Productivity shifts are going to alter the growth of trees. So the first thing that we account for in the economic model is a shift in the growth of trees. It can either be up or it can be down. Keep that in mind. It's going to depend on whatever the ecosystem model projects for a particular species. We also have to account for these disturbance factors. Disturbance factors can basically take an existing forest and convert it to no forest, right? So just keep in mind that the economic model has to account for these types of factors when you're trying to conduct the economic analysis. The model I'll be using maximizes the present value of consumer surplus minus costs. Most models, at least economic models, should do something like this, whether it's at the local level, the national level, or at the global level. It just so happens I'll be talking about analysis based on a global model, but local models should also do the similar kind of thing. The adaptations, the model incorporates adaptations, and these are the adaptations we've accounted for in the model. So we've accounted for the fact that climate change, because it alters the growth rate of trees, it potentially alters the disturbance trees undergo, so it can change the rotation age of forests. So in other words, if you're in a place that is expected to experience increases in disturbance, you may manage that climate change by adapting through increasing or reducing your rotation age, actually, right? If you're going to experience bigger disturbances as a result of climate change, you may adapt by simply removing the timber before it experiences the dieback or the disturbance effect. So this is something that the models need to account for and incorporate. Salvage is another way you might adapt. In some places where trees are killed off, it may be optimal to go in and salvage the timber after it's died off, and you may make that calculation by using the economic model. Also adjusting where species grow. So we saw these big shifts in biomes, or where the optimal location for species to grow is. So economic models have to account for that. That is, the range of economically important species is going to change over time, and we get some idea of that from the ecosystem models, and the economic models have to allow for that by increasing the area available for forests to grow, keeping in mind that economically you may want to increase the area of forests or you may not actually. As I'll show, because forests tend to become much more productive globally, prices fall. And in fact, some places, even though they could increase their forest area dramatically, they don't because it's not an economically optimal or cost-effective adaptation. So these are the adaptations we've tried to include in the model. The scenarios, again, these are the same ones we talked about, just to give you a sense that they're included in the economic modeling. So the first sort of economic result when this is all put together with our global model is that for the most part, forestry becomes much more productive. Forests become more productive globally, so prices actually fall. This is just to try to show the black line is the baseline. Most of the other lines are the climate scenario price lines. Prices fall really from up to about 7%. So it's not a huge reduction in prices. These newer scenarios suggest smaller price declines than we saw earlier with earlier scenarios from climate scenarios in the 90s. But nonetheless, climate change suggests that forestry itself as an economic activity expands, and so therefore prices fall relative to what they would have been in the baseline. In terms of outputs in, or forest area in Asia, and this is again for these same Asian regions, China is in blue, South Asia in red, Southeast Asia in green, and East Asia kind of in purple. What we find is in forest area that forest area declines pretty dramatically for Southeast Asia. We already saw that from the ecosystem results, and the economic models reproducing that. We also saw huge increases, if you recall, in forest area in, for example, China from the ecosystem model. The economic model doesn't reproduce this huge expansion of forest area, mainly because prices fell, so it's not economically advantageous to expand forests quite as dramatically as the ecosystem model suggests, because economically prices fell and we don't need that much forest. So although forest expands, it doesn't expand as dramatically in China. In South Asia and East Asia both experience slight decreases in their total forest area. Output falls pretty dramatically, at least by these projections, for most of Asia with climate change. So most regions, now actually these look pretty dramatic. They're actually not that dramatic. They're really only 5 to 6% reductions, with a 16% reduction in South Asia. Although East Asia gets a huge reduction. Remember, East Asia is pretty small and it's not a huge set of output, so this looks really big. These are actually pretty small output reductions. But they do suggest output reductions, and that the output reductions are growing over time. So most of these decreases occur in the future, and they're in the 5 to 6% range. Although Southeast Asia experiences a slight increase in output initially. Why is that? Why does Southeast Asia, in this particular set of models, experience an increase in output? That's mainly because the long run scenario, if you recall, was a reduction in forest area for Southeast Asia. Some of that was through dieback, and in Southeast Asia their adaptive response to that is to try to increase output, at least in the near term, because many of those forests are actually going to be harmed by climate change in the long run, so they try to take advantage of it at least in the short run, although their long run output is a reduction. Why do some of these models diverge in terms of their results? Again, as noted, we saw these are basically, this is the ecological scenario, this is the economic scenario in terms of the amount of forest land that you would have in China with climate change. Ecological scenario suggests a huge increase in area, but in fact the economic model only uses a little bit of that. Well, the key reason is there again is that prices are falling. Forestry does not, the productivity of forestry does not increase. No, actually, I'm sorry, this is actually a different